Okay, now on to something called rationalising the denominator. Again, a bit like expanding brackets with surds. You probably would have seen this before at GCSE, but if you haven't, don't worry, I will go through it in detail. So what is the crack with this now? Rationalise the denominator means removing the surd from the denominator, so getting rid of this surd, not getting rid of it, but by kind of manipulating it and moving it to the numerator, right? And the way that you do this is you multiply the surd by whatever the surd is on the bottom. So you times it here, in this case by root 2 over root 2. Now, the reason that you can do that is because effectively, right, if you're timesing something by root 2 over root 2, well, what is root 2 divided by root 2? It is simply equal to 1. So effectively, right, root 2 over root 2 is the same thing as timesing the whole thing by 1. And of course, if you times something by 1, you keep it exactly the same. That is why it is a legal move. You're allowed to just times the surd by root 2 over root 2, because effectively you're timesing it by 1. Okay, and then timesing fractions, we're just doing 3 times root 2, which is simply just 3 root 2 over the bottom part, which is going to be root 2 times root 2. We know we can write it as now root 4, because from our laws of surds, right, root a times by root b is equal to the square root of a times by b. We know that. Okay, so then you can just write this a little bit more simply now. Should have kept it in green, but that's fine, as 3 root 2. And then what's the square root of 4? Is simply equal to 2. So there you go. Right, you've rationalised this surd. Okay, it's got the same value. 3 over root 2 is the same thing as 3 root 2 over 2, but you've rationalised it. You've manipulated it so the surd is now no longer on the bottom, but it's on the top. And maybe you're thinking, well, it looks like it's gone from being something more simple to something more complicated. It does look that way, but actually it's more useful to have a surd on the top, rather than the bottom, because like if you're collecting terms, it's easier to have the surd on the top. Okay, so let's go through a couple more examples. Let's go through the first one again. Right, you want to multiply this first one. We want to rationalize it, so you want to times it by the surd on the bottom. So you want to times it through by root 2 over root 2. And again, we can do that because root 2 over root 2 is the same thing as 1. So you're just timesing the thing by 1. So 3 times root 2. We just go and write it as 3 root 2 over root 2 times by root 2. We write it as root 4. Okay, so it's going to be 3 root 2. Isn't that the same question as before? It is. Yeah, sorry. Okay, it's the same question again. Anyway, right, try the your turn now. Okay? Hopefully you've tried it. Let's go through it. Again, you want to times this one now by root 5 over root 5. And then 5 times by root 5, we just write it as 5 root 5 over root 5 times by root 5. We simply write it as root 25. Okay, so it's going to be 5 root 5. Root 25 is, of course, equal to 5. So there you go. Right, you no longer have a surd on the bottom. It's on the top, which is perfect. You've rationalised it. This is your answer. And again, this has got exactly the same value as this. You've just rationalised it, which is lovely. Okay, this one looks a little bit trickier, but it's the same idea going on again. Right, your bottom number, again, you want to rationalise it. Your bottom number is a root 2. You want to times the whole thing, okay, top and bottom by root 2 over root 2. And you just go and consider the numerator part and then the denominator part. So if we just go and consider the numerator, the top part to begin with, okay, I'm going to write it in a bracket to make it look a little bit nicer. We've got 3 plus root 5. We're timesing it by root 2, so just timesing it by root 2. Expanding brackets, kind of usually we like write the root 2 over here, but you can write it like this, that's fine. We're doing 3 times by root 2 is equal to 3 lots of root 2. You've then got root 5 times by root 2, okay, which is equal to root 10, so plus root 10. So that is the numerator part of the surd evaluated. Then of course you've got the bottom part, you've got root 2 times by root 2, which we can just go and write down here. We've got root 2 times root 2, which of course we know is root 4, which is equal to just 2. So overall, right, the top part, we had it as the top part was equal to 3 root 2 plus root 10 over the bottom part went down to 2. So there we go. Okay, so you can see now, perfect, there is no surd on the bottom, they're on the top. You've got to be careful though, right? Can you simplify this any further? You can't here because, right, root 2 and root 10, they're not like terms. Can you simplify root 2 and root 10 any further? You can't, because there's not two numbers that multiply to make those numbers where one of them is a square number. So you can't break it down any further. So this is actually just your answer. Okay, looks messy, doesn't it? But you've rationalized it. The surds are no longer on the bottom, they're on the top, which is useful. Okay, so try to your turn. I'll pause it and you can give this one a go. You can pause it. Sorry, I can't pause it. You can pause it if you need to. Let's go through it. So again, you want to times this one through by root 5 now over root 5 and consider the top to begin with. So I'm going to go and evaluate the numerator to begin with. Okay, so here we're doing, put it into a nice little bracket. We are doing 5, take away root 3. We're timesing it by root 5, expanding your brackets. Okay, 5 times by root 5, we can just go and write as 5 root 5. Negative root 3 times by root 5 is going to be negative root 15. Definitely right. You never write a negative inside the surd. If you're just doing pure maths, not further maths, you're never going to see a negative inside that surd. Okay, so just be careful with that. Good. And then the bottom part, we've got root 5. We're timesing it by root 5. So we've got root 5. We're timesing it by root 5, which of course is equal to root 25, which is equal to 5. Good. So then overall, right, the top part was equal to, this part was equal to 5 root 5 take away root 15. So we've got 5 root 5 take away root 15 over the bottom part, which is equal to 5. Now, you can actually break this down a little bit further because, right, if we write this as two separate fractions, we write it as 5 root 5 over 5, take away root 15 over 5. Well, of course, these 5s here, okay, they cancel to give you 1, they just disappear. So you can write your answer simply as root 5 take away root 15 over 5. Now, right, this means exactly the same thing as this. They're both rationalized. There is no surd on the bottom. They're just different ways of writing the same thing. The question might say, write your answer, for example, as a single fraction. Right, this thing here is a single fraction because you can literally see, right, you've got just one big fraction, whereas this, you've got two separate fractions, right? This being a fraction being over 1. Okay, so just depending on how they want the answer to be written, right, they're both correct. They're both rationalized, just in different forms. Okay? Good. Right, let's go on to another example. So example 11, let's look at rationalizing the denominator again. So same idea. Well, this time actually, right, we've got root 2 plus root 5. The way that you approach this one is you've got to times top and bottom by, it's going to be root 2 take away root 5. And the reason you want to do that, okay, times it by root 2 take away negative root 5. Basically, you flip whatever sign this is, because on the bottom now, right, you've got the difference of two squares, which means the surds are going to cancel out later on, which you will see. So right, if you've got surds on the bottom, you want to flip that sign, but you'll see why now. If we go and consider the numerator though to begin with, okay, so we just go and consider the numerator parts up here. We're doing root 3, we're timesing it by root 2, take away root 5, so we're expanding that single bracket on the top. Okay, so root 3 times by root 2 is going to be root 6. Root 3 times by negative root 5 is going to be negative root 15. Okay, that's your numerator part considered. Okay, then you've got your bottom part, your denominator part. So let's go and write this down here. You've got your denominator part. Then the denominator, we've got root 2 plus root 5. Timesing it by root 2, take away negative root 5. Right, and that is the difference of two squares. You've got something in the form a plus b, a take away b. Therefore, it's going to go, if you expand the brackets, it's going to go into the form a squared take away b squared. Where in our case, right, a is equal to root 2, okay, and b is equal to root 5. So when you expand the brackets, right, it's going to go to a squared, where a is equal to root 2. So it's going to be root 2 squared. Let's write it out. So it's going to be root 2 squared, take away b squared. B is root 5, so take away root 5 squared. And of course here, right, the roots and the squares are going to cancel. They're going to cancel. So you're simply just left with 2 take away 5, which is equal to negative 3. So you can see the surds, they cancel out. Okay, so overall, right, we saw on the numerator part, we got root 6 take away root 15. So we had root 6 take away root 15 on the top over the bottom part, which we saw is equal to negative 3. Now, can you break this down any further? you can't, because root 6 and root 15, you can't simplify them any further. So that is simply your answer. Okay? Good. Onto the your turn. You can give this one a go, pause video, and that's going to be it for this video on rationalizing the denominators. This one, you want to multiply by top and bottom this time by root 7, not take away root 2, but plus root 2, because again, if you do that, you're going to get the difference of two squares on the bottom. Okay, if we go and look at the numerator parts to begin with, right, so we go and consider the numerator NUM, and we go and do root 5 times it by root 7 plus root 2. Okay, expand the brackets, so it's going to give you root 35 plus root 10. Good. You can't simplify it any further, so that's good. The denominator part, again, is the difference of two squares, because you've got something in the form a plus b, a take away b. So where in this case, right, a is equal to root 7 and b is equal to root 2. So a squared take away b squared is what it's going to go into if you expand the brackets. So it's going to be a is root 7. Sorry, my pen pad is getting a bit messy. Root 7 squared, take away b squared is root 2. We're squaring it, so root 7 squared, they're going to cancel, which is going to be 7. They're going to cancel, it's going to be take away 2, is equal to 5. So overall, right, the numerator was equal to root 35 plus root 10 over 7 take away 2 is 5, and that is simply your answer, because you can't, again, break down, right, root 35 or root 10 any further. That is your answer. You've rationalized the denominator. Okay, you can see there is no surd on the bottom. Okay, excellent. I think that is it for this video. It is. Good.